Hello, thank you very much for coming. My name is Warski, and I will try about designing programmer-friendly APIs, but not in general. I'm not brave enough to do that. So I will use Tapir, which is a library I wrote as an example. So what's the rough agenda? So first we will take a look at Tapir itself. There will be a short demo of how the library works, how you actually use it, so that you can get a feel of how the API works. Then we will look at a more general technique that Tapir uses, which is separating the description of the problem we are trying to solve from its interpretation. And finally, we will take a look at some of the design choices that Tapir made. Maybe you will agree with some of them and disagree with some of them. And talk a bit about general goals of the API in that case. So hopefully this applies not only to Tapir but also to a wider set of problems. But yeah, what we'll see. So before continuing into the actual code, a short introduction. As I said, my name is Warski. I'm the co-founder and a software engineer at SoftwareMill, which is a consulting company in Poland. We help companies scale their business through software, which usually means doing some kind of distributed backend system. We specialize in Kafka, Cassandra, Scala, all the fashionable things, blockchain as well. And I'm also doing a couple of open source projects together with other colleagues from the company, such as STTP, Tapir, Macquarie, ElasticMQ, and others. So yeah, so that's the introduction. If you would have any questions along the way, just ask. Okay. So first, before we actually take a look at what Tapir does, let's talk a bit about what's the general problem that we are trying to solve. It's always good to have a problem that you are trying to solve. So in our case, it's HTTP servers, HTTP routes. There's a couple of libraries which have very nice APIs for defining HTTP APIs, right? So there's HTTP, which I guess is the most popular. There's HTTP4S. There's also Play. And all of them work more or less the same. So you have some kind of an internal DSL using which you define the routes that your application should support, right? So here we have an example in HTTP4S, right? So this match statement over here defines a route which, when you go to /hello and provide the query parameter name, you will get back hello name, right? A very simple route. The equivalent in HTTP would be fairly similar. So that's all very nice. But then at some point, we usually want to provide some kind of documentation for our API, right? And that's when we hit the problem because, there's no way to actually translate this opaque function, this opaque match expression into documentation. So, one solution is to write. A popular documentation format is this Swagger or OpenAPI. So one way is to actually write this Swagger YAML file by hand, right? So here we have a corresponding YAML file for that single simple endpoint, right? So you can see that, that's like one line, or 4 lines, depending how you count. And that's, I don't know how many lines, but quite a lot. So I don't know as for you, but I don't want to write that by hand, right? That's not a pleasant job. So I would like to avoid that. And there's clearly a duplication of information here, right? So that's our problem. And another thing is that we also might want to actually somehow convert our server into a client call, right? So these 3 representations, they all store the same information about our endpoints, right? So that's the general problem that we would like to solve, right? We would like to have a single representation of our endpoint, which we can then convert to a server, a client, or documentation, right? So that's the good old dry principle once again. So how to approach solving the problem, right? And there are 2 directions which you might take. One is, then we say, OK, we will write the YAML file. It's painful, but it can be done. right? And we write the YAML file, and then we, basing on the YAML description, we generate code which will contain stubs of our endpoints, right? The pro here, so the good side of that, is that we can do it in multiple languages. We have a single specification language, which is the YAML, right? And then we can translate it into Scala, Java, Go, whatever. There's many translators. The one for Scala is called Guardrail, so we can actually do that as well, right? The bad side here is that you actually have to write the YAML by hand, and that's not a nice thing to do. And there's also some lack of precision, so you can't always, so you don't, there's some information is lost as for the types that you might want to use in your endpoints, right? So the types that you get from the generated, in the generated code from YAML aren't as precise as you might want them to be. The other direction that you might take is use an API in Scala, for example, a real programming language. YAML is not a programming language, at least yet. So you can use a real programming language, describe your API using that language, and then generate the YAML from that, right? And that's the approach that we will take in our case. So there's a couple of projects that implement this approach. There's Endpoints typed API, Row typed schema, and Tapir is also one of them. So the main, you can see that there's quite a lot. So there's 5 that I've enumerated here, maybe more. So the reason that I wrote Tapir is that I wanted to create a nicer and more programmer-friendly API for that exact problem. And maybe you can judge if I'm successful in any way. OK. So before we dive into the details, let's take a look at how Tapir looks like in practice. OK. So we will want to describe 2 endpoints. The first endpoint over here is getting a list of books filtered optional by the year in which they were published, and the maximum number of books that we want to get, right? So a very simple endpoint that you might want to describe. Okay, so the first thing that we have to do when working with Tapir is that we have to import the package so we get access to the actual API. So let's call our endpoint. We will create a description. It will be a value, get books endpoint, right? So now, if you want to start defining an endpoint, we need some starting points, right? The starting point in Tapir is the endpoint value. It comes from the Tapir package, which we have just imported, and it's an empty endpoint. So now we will refine our description, gradually adding more and more detail, right? And at all times, we are only creating a description, so nothing else. It's just a pure description which will be stored in the value. So the first thing we do is we say that this endpoint is actually a get endpoint. So we specify the method, right? Then we specify some inputs. So what kind of information the endpoint should get from the request, right? So it should correspond to the books path. So that's a constant input. Then we should get an optional query parameter. And that query parameter is called year. The other will be called limit. Right? Now, it's quite often HTTP endpoints return some kind of errors, right? They quite often fail. They usually have some kind of failure scenarios. So in case of an error, we want to simply return a string saying like internal server error or not found or something like that. So we will return a string body in case of an error, and in case of success, we will return a JSON body, which will be a list of books. Okay, so we have now described an endpoint, even though we probably don't really know what's happening inside the .in, .out methods and so on. If you read it more or less, in English, you kind of might probably guess what it's doing, right? We have an optional query parameter, which is called year, right? On the output, we have a JSON body, which is a list of books, and so on and so on. So it reads quite naturally. In the same way, we can describe our get book endpoint, right? So again, we start with the empty endpoint. We specify the method. We specify that on the input it's the same path, book. Then we say that another path component. So here we have 2 path components. So the second path component should be a UUID. and it will be called book ID for documentation purposes. And in case of an error, we return a string body. And in case of a success, we return a JSON body, which will be a book, a single book, right? And we can also, provide some more documentation here. So, for example, we can provide an example, which will be our example book instance, right? Okay. So now we have described two endpoints. Okay. So far, so good. We will see what's like inside these descriptions in a second. Any questions so far? Okay. We are good. Okay. So what's the basic idea of how Tapir actually works, right? So on a very high level, what we want to do is we want to describe a function, right? Each HTTP endpoint is in fact a function which takes a request and returns a response, right? So what we want to do is we want to describe this function, right? But not any function. So we're not as ambitious to describing any function. We want to describe a function from request to response. Here the response, because these types are taken from HTTPS, so the response is wrapped in some effect type, right? So there might be some side effects when computing the response. And that's in fact, if you zoom out from the HTTPS library, the basic construct in HTTP4S is something called HTTP roots, and that's more or less corresponds. So this type alias more or less corresponds to this kind of function, right? A function which takes a request and returns a response. Now the problem is that when we use the HTTP4S or HTTP API to actually create this function, right? We define this function that if the path is equal to books and the method to get, then return this and this, right? We can write this function as Scala code, right? So the problem is that it's opaque. We cannot look inside, right? We cannot introspect this description and, for example, instead of actually converting a request to a response, generate documentation, right? So what we need is we need some way of looking inside this definition of the function and seeing like what kind of information is taken from the request and so on, right? So we need this introspection capability. Java solves this by using annotations, right? So here's more or less the same example using annotations as you would do in Spring or JE, right? So here the introspection capabilities are provided by reflection, right? So we annotate. Well, this is kind of a function, right? It's the function which defines the logic of our endpoint. So we annotate this function using annotations, and then at runtime we can introspect this function definition, the metadata using annotations, right? This has some downsides, like annotations have quite a lot of downsides. I think there's a whole blog I wrote about it, so if you're interested, you can take a look. Basically, the main problem is that annotations form like a small language inside Java itself, right? So they have different syntax. They are much less type safe than even regular Java. So it's like a language inside the language, which is quite poor. It doesn't compose. You cannot abstract over annotations, and so on and so on. So annotations, they are a solution, but I think there are better ones as well, right? So the problem that we need to solve here is how to actually capture the structure, right? So the solution is simple, right? Scala is really great, and the programming languages that we use are really great at manipulating data, right? So let's represent the descriptions as data, right? And that's what we do in Tapir, right? An endpoint, the value that we have created, is simply a data structure, a case class of the type endpoint, right? That case class consists of other case classes. The endpoint input is a sealed trait enumerating all the different possible inputs. Same for output, right? We have the error output and the success output, right? So we will represent our endpoint as a value of this type, right? And then we can introspect these values at runtime, right? Using that regular constructs as we manipulate values like normal business values, let's say, in a normal code. Okay, so the basic structure will be the data structure that we will create. Now the API that's like the main focus point here, right? The data structure, like, we can create it by hand, the endpoint and the endpoint input and so on, but it wouldn't look that nice. So we create an API, which are the methods using which we actually manipulate these data structures, using which we enrich them. And these methods and these helper methods, which create the instances of our data structures, are actually the API that the programmer uses, right? So here we have the get method, which enriches our endpoint description with the fact that actually on the input we need to have the get method, right? We have the string body, for example, right? The string body creates an instance of the body input, right? So it's a description which says it's a value which describes the fact that the body that we produce is a string, right? So we have these helper methods which create the instances, and this forms the API. And that's the basic idea of how we work with how we provide the introspection capabilities, right? And then once we have the data, we can actually interpret it in many ways. So we can traverse the case class structure, right? At one time generating a server, at another time generating client or documentation, right? And the interpretation and the introspection of the case class structure is like what we do every day in Scala. Okay, so let's do that. We have our the two endpoints that we have created earlier over here, right? So these are the same endpoints, right? The endpoint class over here, if we jump to definition, we can see that's the true endpoint class from Tapir. As I said, it's a case class. It contains inputs, outputs, and so on, right? We have the query parameters that are optional. So we have these two descriptions, right? So now what we would like to do is we would like to convert this into a server, right? So what we are missing is the actual logic that the endpoints should execute once they are invoked, right? So the first thing we do when we want to interpret things as a server, we need to actually import the interpreter. So we import the interpreter is a member of the Tapir server HTTP4S package. So we import that. And now we can take our getBooks endpoint, right? We can take our getBooks endpoint, and we can convert it to HTTP4S roots, okay? So by adding this import, we actually are adding an extension method to the endpoint called toRoots, right? If we would import the Akka HTTP interpreter, we would have an extension method which would convert the endpoint into an Akka HTTP root without an S. Okay, so here we have the toRoots method, and this method has the nice property that it's actually well typed, right? So what this method needs is the business logic that should be run when this endpoint is executed, right? So if we look here, you can see that we have defined two inputs which are optional ints, and that's also reflected in the type, right? So in the type, the first type parameter specifies the type of inputs that are read from the request, right? So we have specified two things that are read from the request. The second type parameter is the type of the output in case of error, which is a string corresponding to the string body. And the third is, in case of success, corresponding to the JSON body specified here, right? So this is all well typed. And what we need to provide over here is a function which takes in these things that we read from the request, right? You can see that it's all inferred even by IntelliJ. So we need to provide these. So we get on the input these two optional query parameters, and we need to provide either an error output, right? So, but you can see the either over there, right? So we need to provide either a string, which is the error output, or a list of books, which is the success output, right? And that's by using the either left or either right, we specify if this request was handled successfully or not. Okay, so what we do here is we say that we get the year and the limit, which are optional optional parameters, right? And we filter our books list. So we don't have a database, we have a fake database, which is a static list of books, right? Which we'll simply filter by the input. Okay, so what we do is we take our list of books, and yeah, we take the year because it's optional. So we map it. We take the books, filter, year, and here because it's a value class must be equal to whatever is in the input, right? And we do get or else the whole list of books. We do the same with the limit. It's also optional, so if there is a limit, we simply take the number that was requested. Otherwise, we get all the books 1. Yeah, books 1 here as well. Okay, and now we return in this case it will always be a success. So we return a right value without any side effects of books 2, right? Okay, and that's it. That's all that we have to actually do to implement the logic. We can implement the logic for the other endpoint in a very similar way. So we call toRoots, right? Here we have, we can look at the types. So here we get a single input, which is the ID of the book that we want to get, and we have to return either an error or this single book, right? So we get the book ID, and we can do a books.find. We look for the book with the given ID, right? And we can either get, we either find the book, right? And then we return IO right book, or we get a none, and then we return an error, left book with ID, book ID, not found, sorry. Yeah, okay, and that's our logic, right? So what we do here is we take the description, which again is just a case class structure, no dependency on any kind of server, client library, and so on. It's just a case class structure, right? And we convert it to these HTTP4S routes, right? By providing the missing piece of information, which is the server-side logic that should be executed. Okay, so we have our server. Is that clear? Any questions, maybe? Clear. Okay. So now the second thing that we want to do is we want to generate the documentation, right? That was the starting point. So here we need to use another interpreter, right? So we import the OpenAPI interpreter. Again, we import the whole package, and this brings in an extension method which will allow us to convert our endpoints. So here we convert to endpoints. So we get getBooks endpoint and getBook endpoint. So we take the list of these two endpoints and we convert them to the OpenAPI data structure, the Tapir library 10, okay, docs OpenAPI. Okay, so the first step is to convert it into an OpenAPI structure. Again, it's a case class family which corresponds directly to the OpenAPI specification. You can customize it if there's anything that's missing. And then we have to serialize this as YAML, so we call to YAML. Okay, and that's it. We have interpreted our endpoints in two ways, but we are missing the actual serializer. Import Tapir OpenAPI ser c YAML. Okay. Yeah, now works. The final step is to actually run, so expose a server, right? And that depends. So that's like depends on the server interpreter that you are using. Here we are using HTTP4S, right? So that's like if you go to the docs and copy what do you need like to start a simple HTTP4S server. That's what you need to do, right? So the important part here is that we use the roots that we have interpreted, right? We have the roots that are interpreted from Tapir. We use them over here in the router, and we also provide the docs along with some way to serve all the HTTP4S resources under the /docs context path, right? So what we can do now is we can actually try running this. Tap your demo. And we should see that you actually get the generated documentation, okay? It works, I guess. Yeah. So we can see that here we have the books endpoint, right? So we can try it out and execute. And yeah, we get the list of books. So we can try copying in ID, right, which is random, and getting a book by ID. Try it out. We try this, and the response is over here, right? And if we provide an wrong ID, then we get not found, right? So exactly as we have specified in our description. Okay, so this likely worked. So that's basically how Tapir works. Now it's an instance of a more general technique, which is separating the description of the problem, which in our case is the description of the endpoints, from the interpretation, right? The interpretation in our case was either a server or a documentation. You can also generate a client, an HTTP client, right? So as in many cases, the answer to the first problem that we have, that we want to actually, not repeat the information, right, in the YAML and in the endpoint function. So the answer here to that problem is that we add a degree of indirection, and by that we gain a degree of flexibility. And Tapir is by no means the only library using that, quite the contrary. If you look at other popular function libraries, they are doing exactly the same thing. So for example, Dubey is a library for working with SQL databases, right? So what you do in Dubey is you also create values, right? You create values which describe what you want to do with the database, right? So for example, here we have an insert, a method which inserts some data into the users table, right? So, well, it doesn't actually insert the data, it just creates a description of what should be done to insert the data into the database, right? The connection IO value that is returned here is only a description, a data structure that describes what should be done to insert the data, right? And there's a couple of these queries here, and then the nice thing about these queries is that we can actually combine them, so we can create bigger descriptions from smaller descriptions, right? So we can combine a description of how to insert a user with a description of how to make the user an administrator and then count the users, right? And we get a bigger description. It's still a value, right? When we execute this function or when we create a description of an endpoint, nothing happens, right? We just create a case class. Then we provide an interpreter. An interpreter in Dubey is a transactor, and a transactor actually holds a connection pool and knows how to talk to the database, right? So we can then use the interpreter, which is the transactor, to actually traverse whatever is in our data structure and execute it against the database, right? So only when we call the .transact, which corresponds to the interpretation step, we actually do get changes in the database, right? So that's Dubey. And also, where are we? Here. Another popular library, Zio, or Monix, or Cats.io, they use exactly the same technique, right? So if you use Zio or Monix or Cats.io to describe an asynchronous process, right? What you do is you call these methods like .effect, .flatmap, and so on and so on. And each time you call them, you create a data structure which describes what should be done to actually run the asynchronous operation, right? It's not run yet, it's just a description of what should be done, right? Again, if we go, I guess, to flatmap, you can see that what flatmap does, it creates a new instance of a data structure, right? Same thing with our endpoint, same thing with connection IOs, right? So it's basically the same idea. So here, the Zio or the task in the Monix, just a description, then we have to interpret it, right? So what we do is we create an interpreter, which here is called a runtime. And then we can actually run the interpreter using runtime.unsaferun that interprets our description using this interpreter and actually runs the side effect, right? And even more generally, even more generally, these two are both instances of free monads. Free monads were fashionable in Scala like 2 or 3 years ago, maybe. In free monads, you have a base instruction set, which are reified as case classes, right? So again, a data structure which forms the base instruction set. And what free monads give you are 2 operations. One is sequencing 2 operations, which is called flat map, and the other is pure, which is just returning a pure value, right? So we have, and these flat maps and pure in a case class are also, in a free monad, are also represented as case classes, right? So in a free monad, we are able to describe how a program should work using the sequencing from free monad and our base instruction set, right? So if you're interested, there's a whole CATS tutorial on the CATS documentation page, which shows you exactly how to create a description of a program which here interacts with the key value store, right? So what we create here is a description of a program which puts some data and reads some data using a data structure, but then we actually need to provide an interpreter for that, for this to work, right? So this is all the same ideas. So Zio and Dubey are both instantiations of the free monad idea with a very specific instruction set, right? In Zio, this instruction set corresponds to asynchronous operations. In Dubey, the instruction set corresponds to whatever you can do, so that you can talk to a database. Tapir is not a monad because there's no sequencing of operations. We don't describe programs, right? So it's a different kind of structure. But the basic idea of separating the description from the interpretation is still the same. Okay, so that was like the general technique that we are using. So now let's a couple of Tapir design choices that we've made, which impact how you actually work with the API. So first, before we started to write Tapir, there's a couple of principles that we wanted, the properties that we wanted the API to have. So first of all, it should be type safe, right? We are in Scala. If you didn't want to be type safe, we would be doing Ruby or Go or something like that. Second, we want it to be reusable. So we want the descriptions to be reusable. We want to be able to make abstractions. So we want to extract common parts and use them in other endpoint descriptions. Third thing is we would like to have programmer-friendly types. So sometimes when you have libraries which are very type-safe and they check a lot of things at compile time, but then you have to write down the type because it's a public method and it's a good idea to write down the types of public methods, and you get this monstrosity which, well, it's a pain to look at, right? So we would like to have types which are actually which are possible to write down by hand, and which are not scary, right? And if possible, inferable by the IDE. And finally, we would like the API to be explorable, right? So if you are new to the code base, if you are new to the library, you need to learn what it does. We need to understand what it does, right? So auto-completion is a very useful tool when you are exploring a library. Go to definition if you are able to jump to the definition, read the sources and jump around the sources so actually understand what's happening there. So these are all very useful tools when actually trying to learn an API. Okay, so let's look at how the general principle of type safety in case of Tapir looks like, right? So here it's actually a unique feature of Scala which makes it impossible to write Tapir in other languages such as Java or Kotlin, right? So as you have seen, the endpoint descriptions are type safe. So when we try to create the description, when we try to convert the endpoint to a server, we need to provide the logic which is well typed, right? So the information about what are the types of the inputs and so on is encoded somehow in the type of the endpoints, right? So here, when we gradually build the description of the endpoint, we gain more and more information of what are the inputs and the outputs and so on, right? So here, for example, we have a simple endpoint description which takes a single query parameter, which is an int, and the query parameter is called amount, right? So this corresponds. So here we'll be looking only at the first type parameter of the endpoint. So this corresponds to an endpoint which on the input reads an int from the request, right? Then we take this description, right? So this is E1 here and E1 here, right? So that's the description of the endpoint with a single type parameter, with a single query parameter. And we say that we also want to read the body as a string, right? So now we need to do like a type level computation and combine this input with whatever value is provided by the string body. If we go to the definition, we can look at the type over here. You can see that the string body is an input, well, it's both an input and an output, which maps to a string, right? So we need to concatenate the int with the string, right? When we concatenate an int with a string, we get a tuple, right? And this type level computation is actually done using implicits, which is the standard mechanism in Scala. And so on, right? We can add more parameters over here, so we add more inputs. So then we get a tuple which has 3 elements, and so on, right? So here we use the type level computation to actually create a type safe input-output parameter list, right? And then when we convert, so here there's a method which allows to bundle an endpoint with the server logic for some effect type. So when we add the server logic to an endpoint, we actually have the types correctly inferred, right? We get on the input as int, string, and UID, so that's the tuple that we have specified. Okay, and that's possible thanks to the fact that Scala actually allows doing type level computations. Okay, so that was type safety. What about reusability? So we have we come back to our endpoints that we have defined before. One thing that is not that nice about these two descriptions is that a lot of information is repeated here, right? Both are get endpoints which map to the books path, and in case of error return, well, here in case of error we return a status code and a string body, right? So that's a bit richer, but it's basically copy paste as you can see, right? So whenever we see code that's copy pasted, we will probably want to extract this as a common common thing, right? And that's exactly what we can do, right? We are manipulating values. More importantly, these are immutable values, so we can use them multiple times. We can reuse them, manipulate, and so on and so on. So what we can do is we can create our own base endpoint, right? So maybe all of the endpoints in our API start with the /books prefix, right? So we can create a base endpoint. So we take the empty endpoint. We say that our base endpoint will always be a get, because that's what's repeated here. It will correspond to the books context path, and in case of error, it will return this thing over here, right? So that's like, and we can add the type annotation. Why not? And format the code. Okay, so that's our base endpoint, right? That's the common part, and we can actually now use it over here. So instead of this code, which is repeated, you can just say base endpoint and base endpoint, and we are done, right? We can still, like, using very standard tools, go to definition. If we don't know what base endpoint is, we can just jump to the definition using the whatever the IDE gives us, right? And that way we are able to extract common things. This description over here is an immutable value, right? It's a case class. We can use it multiple times and customize in different ways, right? As all other immutable values. And this can be a method parameterized with other things, and so on and so on. So this representation of description as a value is actually gives us a lot of abstraction and reusability possibilities. Okay. Now about the shape. That's a bit of a controversial thing as well. When you want to describe the function, the function that corresponds to the endpoint, you have to decide, like, what's the shape of the function that you want to describe. Right? Do you want to describe any type of function which takes any kind of inputs and outputs, right? Well, maybe yes. However, in 99% of cases, the type of things you return in case of error is different from the type of things you return in case of success, right? So your error output is different from your success output, right? So maybe it makes sense to actually represent this in the API as a first-class construct and allow the users and force the users as well, right, in that case, to always describe functions of shape which take an input and return either success or error, right? And that's what Tapir does, right? We have the error outputs and the success outputs. That's also what, for example, Zio does, right? They have the error channel and the success channel. They are separate types, right? And that's also like directly corresponds to the shape of the function that you have to provide when defining server logic, right? You have to provide a function which returns either error or success. Okay. So that's also an important design decision that you have to make. Then you have to think like, what can be the shape of an input, right? We have seen that we can create products, right? If we combine two inputs, we can create an input which is a product of these two values, right? Here we have an input which consists of a query parameter and a header value, right? By the way, inputs are also case classes. They're also values. They can also be reused, abstracted over, and so on and so on. So here we have a composite input which combines two values, and it can be used in multiple ways. That's also thanks to the fact that we use data. Well, products are easy, but what about coproducts, right? Do we want to create inputs which actually are either, here we have either an apple or an orange, right? Do we want to create an input which is either a query parameter or a header value? Well, at first sight, it seems like logical. It's symmetrical, right? We have products. Why not coproducts? But then, when you actually try to implement this, you find out it complicates the API a lot. And there's little practical usage. You rarely want to have on the input either a query parameter or a header value, right? So that's not currently possible. I guess the biggest problem over here is that once you start interpreting these as clients, these inputs as clients, you need some kind of discriminator to know which branch to take, right? So these discriminators in case of coproducts are really, really tricky, and that's why the shape of input is restricted to be a product, right? And that's only valid in this domain, right? If you wanted to describe functions for another domain, that might be a different case. Symmetrically, in case of outputs, right? In case of outputs, like we have the top-level coproduct already, right? We have the we return either an error or success, right? So maybe that's enough to support coproducts. Turns out it's not enough because people very often want to discriminate based on the status code, right? So they want to return different JSON bodies. For example, if the error status code was 404, you return this JSON. If it was unauthorized, you return this JSON, and so on, right? So you need this additional coproduct level in the outputs as well. But here we have a very good discriminator value, which based on which we can decide which branch to take, which is the status code, right? We get when we get a response from the server, when we interpret things as a client, we can actually see what is the status code, so we know how to deserialize the response, right? So here we get a good discriminator. Again, it's not perfect, unfortunately. One, there's no exhaustivity check, so these mappings over here that you can see that actually define the coproduct cases, they are all values, but there's no check that we have actually covered every possible value, right? The second thing is that to implement that, you actually have to rely on class tags. So the status mapping over here captures the class tag of the not found class, right? And then it's compared at runtime using isInstance. So I don't know of a better way to implement it. If you know, please let me know. Okay, so as far as type safety is concerned, it's very nice to make your library type safe, but you also should decide what should be the limits of the type safety that you actually want to provide, right? Sometimes verifying additional properties and compile time will actually be quite expensive in terms of how much complicated the type signatures get, right? So maybe it's not worth verifying everything at compile time. You need to hit a balance between the usability of the types and the properties that you check, right? So in case of Tapir, for example, what we do check are the types of the inputs and outputs, right? So we do verify at compile time that the server logic that you provide actually takes an integer and returns a string, right? That is verified. What is not verified is, for example, we can specify that we read the body as both a string and an array of byte, right? And usually you can't do that. You can only consume the body once, right? So that's actually would cause a runtime exception. So that's a property that we do not verify at compile time, right? So it's a trade-off. Actually, verifying that we specify body only once would require encoding in the signature that you have specified a body or a query parameter and so on and so on. So it would complicate the signatures a lot, right? So you have to you need to decide what kind of types, what kind of properties you actually want to verify here. Okay. Going on. That's a very Scala thing. That's a very Scala specific thing, right? So you probably didn't notice, but if you provide the server logic over here, right? That's an endpoint which takes a single parameter which is an int. So you have to provide a function which converts an int to the result, right? And that's all nice. Now, let's say we have two parameters over here, right? So we have on the input a tuple, which is an int and a string, right? So now, what's the type of the server logic function, right? It's a function, a single parameter function, which takes a tuple of two elements, right? And that is distinct from a function which takes two parameters and returns the same thing, right? So we can either have a function which takes a tuple a, b, and returns f, right? Or we can have some response, let's say. Or we can have a function which actually would be, so that would be the tuple version, right? Or we can have a two-argument function which returns the same result, right? And these are the same thing, right? It doesn't matter if you have a one-parameter function which takes a two-tuple or a two-parameter function. But in Scala, it's a different, like, instances of a different thing, right? So there are two choices here, right? We could either try to convert the type of the function that we need here from a tuple to a function 2, right? And then the user would be able to write using syntax like this, right? It's a two-parameter function, right? Or we can just say, please provide a single parameter function which takes a tuple. And it turns out you can do the conversion using implicits as well. But then again, you wouldn't get the nice hint over here. You would just see that you need to provide a function from AB where AB something, something. And so it would be a very long error message or a very long hint. But also the error reporting would suffer a lot, right? So here, if you provide a function which has the wrong type, you can clearly see the types that are wrong, right? So we can actually try that. We can. That's a double, right? Okay, no, that I would need to extract the function as a standalone. So, but if you actually try to provide the wrong type of the type function of the wrong type, you will get a nice error. And if we tried to convert these functions into their proper arity, the type errors would suffer a lot, right? So here again, it's a very Scala-specific thing that the two function is a different thing from a function that takes two tuple. So we have to live with that. Another design choice is what should be the type of the basic input, right? And that's something that's currently discussed on GitHub if you would like to take part. Like if you want to represent an empty endpoint, right? An empty endpoint doesn't take any values, right? So very naturally, an empty input is a unit, right? So quite naturally, again, the first type parameter should be a unit. Now, but what should be the default output, right? should it also, well, default output would be an empty endpoint, takes no inputs and returns 200 OK, right? So in case of success, it's also a unit, right? So an empty output. What about the error case, right? Should it be symmetrical? Like it looks nice if it's symmetrical because there are 3 units over here, right? But then maybe you want to describe endpoints which never fail. I'm not sure if such endpoints exist in practice, but maybe you want to do that, right? So then you would actually want to use nothing here. Okay, so these are, but then you also have the, maybe you want to describe an endpoint which always fails and never succeeds, right? So again, this would complicate the API. So it's not quite clear which direction to go. Okay, and the last two things that we are thinking about, how to model headers, right? So if you work with HTTP, you very often specify headers, right? And both in HTTP and HTTP4S, you actually have a type-safe header model. So this is again a question of how far do we want to push the type safety, right? So in HTTP and HTTP4S, they have the type-safe header model, right? So for example, there's the content type header, which is a separate type. It has a media type and so on. And it seems like a very nice idea, right? But then in practice, you just want to send, you just want to set a reply where the content type is application JSON, and you end up looking for these well, that's a technical thing. They use the backticks thing, so they are not really searchable by autocomplete. So you keep looking for them, and then you have to find the media type. So you start thinking like, where do I take the media type from, and so on and so on. And all you want to do is simply send the content type application JSON, right? So it's and it seems like a nice idea. In practice, it's often a pain. So yeah, what do you do with it? So currently, there's like an intermediate solution is just to have constants for headers. So that's not very type safe, but again, it's quite easy to use. So yeah, so I'm not sure which way should we go. Should we go the type safe header model way, or should we, which also would mean actually copying the whole type safe meta model from either HTTP or HTTP4S, because they are of course separate. So it would be nice to have a single meta model of the HTTP and Scala, but then creating 3 separate ones, yeah. So that's a tricky question. How far we want to go with the type safety over here. And finally, the last point that I have is that it's always good to have a backdoor, right? However, whatever nice API we actually create, there will always be a case that we won't cover, right? So it's good to have a backdoor, which would probably mean that our API, that the usage of our API is not that nice, but you can actually do that, right? So in case of Tapir, the backdoor is describing an endpoint which takes everything and returns anything, right? So here we describe an endpoint which takes all headers, all query parameters, all path components, reads the body as a stream because we don't want to be blocking, outputs an arbitrary number of headers and an arbitrary body, right? So using this description, it's a description of every endpoint, right? We take in all the data from the request and produce any kind of response. It's not very informative if you read it, but it's possible, right? Just in case if there are any problems. Okay, so that's, I guess, yeah, that's what I had. So as a summary, as a summary of how the Tapir API is actually created. So the general technique here is to separate the description of our problem. Our problem here was describing HTTP endpoints from its interpretation using immutable values, case classes, and so on, right? So we have the case classes, the data structure that you create, and the API actually the helper method with which we define, with which we create instances of these data structures, right? We are type safe as much as possible, but to a reasonable degree, right? We have to pick which properties we want to verify at compile time so that our types are nice, programmer friendly, and so on. The API is also restricted, like the shape of the endpoint that you create. These are in essence functions, but we restrict the shape of the function that you want to describe so that it suits our domain domain better. And finally, there's always a backdoor. So if the API didn't, the API authors won't always know about all the possible problems that may arise. So there is a backdoor. So if you would like to take a look at the code from this presentation, it's on GitHub, as well as Tapir itself. So if you would have any suggestions on how to improve the API or take part in any of the discussions regarding the design decisions that I mentioned, you are invited to do so. Also, we have a Scala newsletter. If it's a weekly portion of Scala news, if you'd like to subscribe, check it out as well. And yeah, I'm here for the rest of the conference, and maybe you have any questions. Yeah.
Any support for Scala.js so that you can?
Yeah, in theory it would be of course possible. It's not implemented yet. But yeah, there's a ticket, so if anybody would like to do that, they are more than welcome. But yeah, so there's an well, the idea is quite simple, right? You take the endpoint description, you convert it to an HTTP client, and then HTTP has a Scala.js version. So you can use the endpoint description from JavaScript to actually call the server as well, right? So most of the building blocks are there, apart from actually compiling Tapir into JavaScript. Yeah.
Yeah. So one of the things with the HTTP4S is that I've had to deal with things like encoders and decoders for CSV files and Excel files and all this sort of stuff. Does that fit within the current API?
Okay. Yeah. So yeah, I didn't have enough time. There is yeah, Tapir has its own notion of codecs. Okay, so yeah, each library needs its own codecs, right? We have encoders and decoders in Cersei. What you said in HTTP4S, there are also encoders, decoders for. These are actually encoders, decoders for bodies, right? So they take in the body as a stream and convert it to something, right? And yeah, in Tapir there's a notion of codec. It's a bit richer because it contains also the information about the media type. For which the codec corresponds to, and it contains some metadata like schema for documentation and so on. But it's quite easy to create your own codec. So you can take an existing FS2 codec, Cersei codec, anything, and convert it to a Tapir codec. So basically, it's just implementing encode, decode functions. And maybe you want to provide the schema by hand if it can't be automatically generated. But yeah, the reason why you actually need it will be 38. Why you actually need more complicated codecs is that if you want to encode a string, you can do it in a couple of ways, right? So it's a different codec when you want to encode a string as a text plain media type, and it's a different output if you want to encode it as JSON, because then you add the quotes, for example, right? So you actually need different codecs depending on the context, right? So that's also why you have the string body and the JSON body. So the string body uses the text plain codec, right? And the JSON body requires a JSON codec for the given type, which actually knows how to encode to JSON, right? So, yeah, but it's all in docs. It's quite easy to create custom codecs.
Okay, so also on the JSON then, if I'm not using Cersei but using something else, there'd be no problem.
Yeah, so the out-of-the-box integration with Play and me JSON, something like that. But yeah, again, it's very easy to I can show you the code. Tapir, Cersei, yeah. So that's basically the code that you need to write to wrap. So here we are wrapping Cersei encoders and decoders into a JSON codec, right? So we are wrapping these Cersei decodecs into a Tapir codec, and it's basically, encoding is calling the pretty printer, right? Decoding is just converting errors to the errors that are in Tapir, and that's it. The additional thing that we need here is also the schema, right? So we want to automatically derive the schema for the case class for documentation. So that's the third case class, and that's generated using Magnolia by default. Yeah. Okay, thank you very much then. Have a good conference.